Then we need to proceed and create our data resources, because when we jump to main, it will be depending on the data locals, variables, and also the providers and the versions. For the data resources, we'll initialize the first two as follows. So for the AWS partition, we'll call it current. The next one will be AWS caller identity, so call it current. Then let's create the session context, which will provide to us the details of the current STS assumed role. Let's add it, AWS IAM session context. It will return the current context of the assumed role, and it will have an ARN. It will come from the data.callerIdentity.current.arn. Then we also need the availability zones. We'll use available as the identifier. It's usually good to read this from the data resource, because some regions have fewer availability zones. So with this data resource, you can read them, and then you can get the number without having to hard code it. Then we need to create the load balancer controller policies. So we'll start with the trust policy. We'll just do data.aws IAM policy. So we are creating a policy document, not the policy itself. And then this will be the name of the policy. So the content for this IAM policy that we are creating here, there will be two of them. It will also be attached to the description of this video. So we have the trust policy and also the controller policy documents. So for the trust policy, it's a short one. It's not as lengthy as the controller policy. So I'll just paste it in and then walk through it quickly. We have a single statement that allows STS assume policy with web identity. So it will be using a federated access, and then this is the identifier for the federated access, which will be the OIDC provider of our account. It will be located in the current region in which you are deploying the cluster, and then it will be using the local.oidc ID, which we'll be creating just in a bit. Then we'll have various conditions. The request using this policy has to come from STS, and then it has to match this value. The same down here, the string has to match this value, and also it has to come from system, service account, keep system, then AWS load balancer controller. So these are just additional conditions to make sure that the policy is assumed by the right resource. So let's create the local OIDC ID. We can do that under the locals so that we keep everything together. Can have that, and then we can initialize the locals block. So we'll get the OIDC issuer from our cluster like this. Since it's a HTTPS URL with the ID at the end, we'll be splitting it using the /, and then to get the ID, you have to get the length of the array. So when you split a string using the Terraform function split, it will give you an array of the tokens that have been split. And then we'll be getting the length of our array or of our list. And then finally, we'll be getting the OIDC ID. We'll be doing local.oidc issuer. Since it's a list, we can select the items using an index. So we have the length, we just subtract 1. Since a list starts from index 0, the last item, which is the ID, will be the index of length minus 1. So once we have the ID, you can go back to the data.tf. You can see the error has gone here. And then this ID will also be coming from the Fargate module, basically the cluster that will be outputting this OIDC issuer. Lastly, we have another IAM policy document. And then this one will be named load balancer controller. And then it will have the following content that will be shared. This policy is lengthy. You can get a reference to it from the AWS documentation, and the link will be shared in the description. So the policy starts at the top here for the IAM permissions, and then you can see we have EC2 and load balancing permissions for the controller. We have the WAF, the firewall, and then we also have ACM to allow the controller to list and describe certificates. We also have permissions for the AWS Shield. The load balancer controller may have to create some rules for the firewall and also for the shield. The shield basically protects your applications from DDoS attacks. Then we also have EC2 permissions here for authorizing security group ingress and also revoking security group ingress rules. So this will allow the load balancer controller to create and remove ingress rules to a security group. And also you can see it has permissions to create the security groups, to attach tags to EC2 instances or to EC2 resources. And here you can see we are creating tags on security groups. These are the permissions that the load balancer controller will be using. Some of them are restricted, some of them are open. So that's it for the data resources. So let's just review what we've done. We started with the partition, the caller identity, the IAM session context, and then we went ahead and fetched the availability zones, and we created the 2 policy documents. Now, before populating our main.tf, we need to populate our modules. So we only have 3 modules for now. So we'll start with our security group, then move to the profile, and then move to the bigger module, which is the cluster.